Hello everyone, my name is Niels Snow. I, along with Dr. Yin, extended the applications of this mass spring system that Dr. Yin has been working on for a little while to include measuring for gas density at various different pressures through a added mass correlation, which I'll talk a little bit more about today. Just kind of the importance of measuring that change in density. I mean, gases are very highly compressible, and ultimately the reservoir conditions are very different than surface conditions. So understanding how that volume or density of the gas is going to change from the reservoir to the surface is really important for determining kind of the economics of the whole reservoir, whether it's profitable at all, and also sizing that surface equipment. And there are several methods out there, several experiments, several correlations for kind of measuring this change. However, these experiments can be very expensive. These correlations are often too simple or inaccurate for the mixtures that we're finding in reservoirs. And so our goal of this experiment is to create a inexpensive, kind of simple yet accurate alternative to what's already in the industry. So this is kind of the basic experiment setup. Kind of some important things to note here. We have our gas right here. We use methane, nitrogen, and CO2 in this experiment. We're pressuring up this sort of vessel with a sphere of known mass that's connected to a spring here. This solenoid will actually cause this sphere to oscillate due to this magnet that's been drilled into it. And essentially this oscilloscope, or we also use the frequency reader, will pick up kind of the frequency that this sphere is oscillating at. And so essentially what we're doing in this experiment is we're pressuring up this vessel to different pressures with different gases, and then seeing how that is affecting the frequency. And those are just some more pictures of kind of the general setup of the experiment. And our whole experiment is based on these three equations. Essentially, if we assume this spring constant to be constant, and we pick up the frequency, we can find out the total mass. From that total mass, we can get the added mass, which then we can correlate to the density of the gas using this simple correlation. Kind of the biggest conclusion we made in this experiment is really that this equation, which correlates the added mass in linear motion to the gas of density, essentially does not apply to oscillatory motion. And how we can see this is that the added mass that we're actually measuring in the oscillatory motion is higher than the theoretical or literature values that we're supposed to be. And of course, if the added mass is wrong, then we're actually calculating a higher gas density than the literature as well. And so what we did is we actually back calculated a new added mass factor, basically this number right here. And taking the average between all the different experiments, we saw that we were seeing a 26% higher change in added mass. And when we created a new constant essentially for that, we actually saw a lot better correlation. Up here is kind of the original values, and down here is with that new factor. And as you can see, they can correlate a lot quicker. So essentially, we believe that we've potentially discovered a new constant for oscillatory motion. And so this method is really effective, and we believe it has a large future in measuring gas density. There are a few challenges to it. The biggest one I'll highlight is this changing spring constant. From the beginning to the end of the experiment, we saw around a 2% change in its stiffness, which of course affects all of our calculations. Some more experiments that we want to do with this. We want to continue our research with gases, especially measure different gas mixtures and their density changes at different pressures. We want to be able to change that temperature inside the pressure vessel. And we also want to, if we can calculate the density of the gas, we should be able to create some sort of gas viscosity correlation as well. So I want to give thanks to a few people that made this research possible. And if you have any questions, feel free to, here's my email right here, and this is Dr. Yin's email right here. And so thanks for staying and spend your time here. Let us know if you have any questions.